Today's agenda, I'm going to talk about the current state of business rules and the decision model and its role in requirements. We get a mix of people in the webinar, those people who have seen the decision model before, those who are new to the decision model. I'm going to spend a little bit of time refreshing on the decision model, introducing the decision model to those who haven't joined it, and then I'm going to talk about the first step framework, a framework that incorporates the decision model into a framework for requirements that has been a significant accelerator for people building the requirements, particularly around agile projects. So that's the agenda for today. I'm going to start talking about the great big ball of mud. The big ball of mud is what Foot and Yoda famously called our software systems in the early 70s, and what our architecture looked like in software systems in the early 70s. And what they meant by the big ball of mud was that systems were undifferentiated, one big, huge piece of code, typically COBOL code or Fortran code, but everything was mixed up in that code. The data, the reporting, the code itself, the presentation component was all mixed up in one big piece of code. And since that time, we've discovered that that's not the way to run a railroad. That's not the way to build a business system. That's not the way to architect a business system. We have to separate these concerns. We have to separate them to simplify them and to make them manageable and to make them sustainable. And the first great moment of separation of concerns happened when Ted Clodd invented the relational model of data in 1970 and gave us a universal model of data which was platform or technology independent. So once we had such an independent platform, data platform which was independent of technology, then all our technology vendors could build to that platform. And suddenly we could have multiple different systems writing to the same database, and we could separate our data from the actual business system. Once we separated the data, we could separate the reporting component. And then in the 1980s, we started separating the presentation component with client-server architecture, which ultimately led to the current state of the web. And little by little, we separated all these components from the architecture. However, if you look at today's modern architecture, you will find layers of architecture for the data. You'll find layers of architecture for workflow. You'll find layers of architecture for the user interface. You'll find multiple different layers, but the one layer of architecture you're not going to find is the business logic layer. Why do we not separate the business logic? Why do we have business logic in every tier of the architecture? Why do we have business logic replicated one system after another? Why do we have business logic mixed up with the rest of the application, mixed up in the presentation layer, mixed up in the reporting layer, mixed up in the data layer? The reason I think we have that, and the reason for this problem, is because there isn't a really good model of logic that allows us, a technology-independent model of logic that allows us to separate the logic from the rest of the technology, from the rest of the architecture, I should say. And where does that lead to? That leads to real problems in the rest of the architecture. Look at this business process model. This business process model was presented to us by a client some years ago when they asked us to help them with their business rules. Now, they had done a really good job of separating their business rules. Each of those little red numbers in each of those task boxes represents a business rule. So they'd actually separated their business rules, done what their consultants had told them to do. They built a catalog of business rules. And yet, notwithstanding that, this process model is just plain ugly. It's very complex. It became unsustainable, unmanageable over time, because the truth of the matter is, even though they had separated their business rules from their process model, the process model still incorporated a lot of logic. I'm going to show you in a few slides just exactly how that logic was mixed up with the rest of the process. The key is separating, the slide keeps overshooting, there we go. The key was separating the logic from the process. If you look at this process, you'll see a dramatic improvement. The process has been simplified very significantly by removing the logic from the process and separating the logic into its own separate model, a model of logic. Now the process is purely sequential activity, and all the information in the logic is about that sequential activity. Where did we put the logic? What happened to the logic that before was mixed up in the process? Well, what we've done is we've separated it and moved it into its own model, a model of logic. Now that model of logic looks somewhat different to a process model. You'll see that the model of the decision model is represented by a little blue octagon and some green tablets, and they're connected to each other. I'm going to explain to you very briefly about that model and what constitutes that model and how that model is made up and how that model more accurately represents logic and why it represents logic so much better than would be represented if that logic was represented in a process model. And the pieces of the decision model we'll discuss very briefly. They're the rule family table, and the atomic logic statement, the rows that make up the rule family table. Let's examine the pieces one at a time. Before we do, I promise to explain to you how we separate the logic from the process and what that does to the process. To do that, let's just take a second to look at this slide together. Look at option 1 on the slide. In option 1, we do the following, and we just follow the happy path of this process. We ascertain a person's employment history. If it's good, we ascertain person's debt. If it's low, we set person's credit rating to A. That's simple enough, very straightforward. Look at option 2 of this process. In option 2, we start by ascertaining person's debt. If it's low, we ascertain person's employment history. If it's good, we set person's credit rating to A. So, what is the difference between option 1 and option 2? Is there a difference? If you take a moment to study option 1 and option 2, what you're going to discover is actually they're one and the same process. The only difference is the sequence in which we execute the logic. But the logic simply determines a person's history, employment history, determines a person's debt, and based upon that, sets a person's credit rating. Now, because sequence doesn't matter in this process, it means that we really need to be very suspicious of this process. We need to think to ourselves, if the sequence doesn't matter, is this really a truly representative process? Is this an appropriate model of process? Does sequence matter? Well, sequence doesn't matter, because if you look at option 3, you'll find that, well, because actually, if you look at option 1 and 2, see, all that's different between the two is the sequence, and therefore sequence doesn't matter, which means to say that this is not really truthfully a process. This is really logic hidden in a process clothing. Option 3 is really an appropriate way to represent it. Simply have a process task that is a decision task. You see it's a decision task because it's got that decision icon in it, the octagon in it that represents a decision, and we simply call it determine person's credit rating, and we let the decision task do the work